Hey everyone! Today we're going to be talking about angles of triangles. Let's read our first theorem, which states the sum of the measures of the angles of a triangle is 180 degrees. So using our picture here, in order to put that into a mathematical statement, let's say that this measure is x degrees, the measure of this angle is y degrees, and the measure of this angle is z degrees. All we have to do is add x, y, and z together and set that equal to 180 degrees. We can put that theorem into play in example 1 here. Now we're given the measure of angle S to be 67 degrees, and we're given the measure of angle R to be 54 degrees. Now the question is asking us to find the measure of angle T in triangle RST. So, using our angle sum theorem, we know that R plus S plus T all add up to 180 degrees. So we usually like to plug a variable in for an unknown value. So now let's write a mathematical statement similar to the one that's given in our theorem. Adding these three angles together, we end up with 54 degrees plus 67 degrees plus x degrees is equal to 180. Now let's solve for x. Let's combine 54 and 67 together. When we add those two together, we end up with 121 plus x set equal to 180. Now that all like terms are combined on the left side of the equation, let's finish this off by isolating x and subtract 121 from both sides. That means now we have x isolated, and 180 minus 121 is 59 degrees. So to answer the question, find the measure of angle T, we can now say that the measure of angle T is equal to 59 degrees. Let's apply this theorem one more time in this example. Example 2 states that we want to find the value of each variable in triangle DCE. So we may need to apply other previous knowledge in order to answer the question. Now we have the measure of angle D to be 55 degrees, and we want to find the value of each variable. So we need to find the value of x and the value of y. Now, one concept that we've recently reviewed from our prior chapter is that vertical angles are congruent. So we know that the measure of angle x is also 85 degrees. Using our diagram as a tool, we'll just plug 85 in for that angle and then apply our theorem where the angles of our triangle all add up to 180 degrees. So let's write a mathematical statement. We have that 55 plus 85 plus y is equal to 180. Now let's combine like terms and isolate our variable. So we know that 55 plus 85 is 140. Plus y equals 180. Now let's isolate our y all the way and subtract 140 from both sides. So I subtract 140. Y is now isolated and equal to 40 degrees. Now we know that x is 40 degrees, and also previously found x is equal to 85 degrees. Now let's take a look at our next theorem. Our next theorem, which is theorem 5.2, states that the acute angles of a right triangle are complementary. And recall from our prior knowledge that complementary means that the angle measures add up to 90 degrees. So we know that the angles of a triangle add up to 180. So if we take into account that the right angle is 90 degrees, we can subtract that from the 180 and get that x and y are complementary. Let's apply this theorem in this example, which states, find measure of angle A and the measure of angle B in our right triangle ABC. Again, since we know that all three angles add up to 180, and it's given that angle C is a 90-degree angle, we can now simplify our statement and write an algebraic equation where 2x plus 3x is equal to 90 degrees. So let's combine like terms and solve for x. 2x plus 3x gives us 5x, set equal to the 90 degrees. Then divide both sides by 5, and we get that x is equal to 18. So now that we've found the value of x, let's make sure that we answer the question. The question asks us to find the measure of angle A and the measure of angle B. So let's finish this off. The measure of angle A is equal to 2x. So we need to plug the value of x, which is 18, in to our expression, and we end up with 36 degrees for the measure of angle A. Let's also find the measure of angle B. Now, remember, it said that 3x is the measure of angle B. So, we now know the measure of angle B is equal to 3x, and plugging 18 in, we get 54 degrees for the measure of angle B. Now let's look at our last theorem for the day. Our theorem 5.3 states that the measure of each angle of an equiangular triangle is 60 degrees. Now, first of all, an equiangular triangle is one such that all of the angles are equal to each other. So let's make a note of that here. An equiangular triangle is a triangle with three congruent angles. So, we may now deduce and use as a shortcut that each angle is 60 degrees when this information is given. Now let's find the value of x in this diagram, utilizing our knowledge that all of the angles of an equiangular triangle are 60 degrees. So notice in this diagram, each of the angles have the same amount of arcs. Remember, this is what we use in a diagram to indicate that all of the angles are congruent to each other. Since we have this fact in our diagram, we may now use our shortcut from our previous theorem and state that each one of these angles is 60 degrees. Now, the angle that's most useful is this one right here, because we're asked to find the value of x, and x forms a linear pair with this measure of angle 60. So, let's write an algebraic statement in order to find the value of x. So 60 plus x is equal to 180. And recall that this is because a linear pair is supplementary. So let's finish this off. Isolate our variable by subtracting 60 from both sides. So we end up with x is equal to 120 degrees. Now that we have reviewed theorems pertaining to angles of a triangle, this concludes our lesson.
Made with Doodlecast Pro.